Okay, Algebra 1, Chapter 12 review. Here we go. We've got 25 questions to get through, so let's get to it. Question number 1, find the mean of the data set above and round to the nearest hundredth. I won't read the data set numbers to you, but we'll go ahead and total those up. And then we have a total of 8 different values. Okay, so when I total those 8 numbers up, we get a total of 383. Then we're going to divide that by our 8 pieces of data. And so that gives us 47.875. And our instructions tell us to round to the nearest hundredth. So this is the hundredths place. That 5 tells us it needs to go up. So that's going to be approximately 47.88. Question number 1. Question number 2 is going to ask us to find the median. So first we need to make sure that our pieces of data are in order from least to greatest. So that would be 36, 37, 40, 43, 43, 44, 45, and 95. And so our 2 terms that are in the middle are going to be the 43s. So we don't have to average those. If those numbers were different, we would add them together and divide by 2. Obviously, if they're both 43, then our median is going to be 43. So the answer to number 2 is 43. And then number 3 is even easier, because technically I've already boxed around the mean, because that's the one that, or excuse me, the mode, because that's the one that's occurred the most, and that's going to be 43. So we are off and running with the first 3 questions. Let's go ahead and look at question number 4. Question number 4 is going to ask us to find the mean absolute deviation and round it to the nearest tenth. The first thing we need to find is the mean. And so, a little crazy on the pen there. And so we're going to take 3, 9, 4, 8, 6, and we're going to add those together. That's going to give us a total of 30. Then we divide that by the number of pieces of data that we have. So divided by 5. So our mean is going to be 6. So what that does for us when we're going to find the mean absolute deviation is now we're going to take each one of those data pieces, and we are going to subtract the mean from it and take its absolute value. So it's going to be 3 minus 6 plus 9 minus 6 plus 4 minus 6 plus 8 minus 6 plus 6 minus 6. And again, those are all absolute values. So 3 minus 6 is negative 3, absolute value is 3. 9 minus 6 is 3, absolute value is 3. 4 minus 6 is negative 2, absolute value is 2. 8 minus 6 is 2, absolute value is 2. And 6 minus 6 is 0, so that distance to 0 is going to be just 0. So we've got 6, 8, we have 10 as our total. We're going to divide that by our number of data set, not our mean. We're going to divide it by the number of data, and that's 5. So that gives us our mean absolute is 2. Okay, number 5. Number 5, we're going to find our variance for the data 17, 10, 11, and 14. So again, we need to take our data, and what we need to do is find the mean. So when we total that up, it totals to 52. And to find the mean, we're going to divide that by 4. So our mean is 13. So in this case, when we're finding the variance, we're going to take each piece of data, we're not doing the absolute value on this one, and subtract the mean, and then we square it. Okay, so 17 minus 13, that's going to be 4. 4 squared is 16. 10 minus 13 is going to be negative 3. Negative 3 times negative 3 is positive 9. 11 minus 13 is negative 2. Negative 2 times negative 2 is positive 4. And 14 minus 13 is 1. And 1 times 1 is just 1. So 16 plus 9 is 25. 25 plus 4 is 29. 29 plus 1 is 30. Then we're going to take that and we're going to divide it by our number of pieces of data. And then I'm just going to reduce that fraction. So that's going to end up 15 over 2. So my answer to number 5, the variance, is 15 over 2. Don't take it any further. Don't divide it to make it a decimal. Just leave it 15 over 2, and that will be acceptable. Okay, number 6, find the standard deviation of the data set. Again, we changed that to problem number 5. Okay, so to find the standard deviation, I need to know the variance. So the variance from number 5 was 15 over 2. And to find the standard deviation, all we do is take the square root of 15 over 2. And that is our answer to number 6, the square root of 15 over 2. You could make it a decimal if you wanted, but I would stop here just to save some time. Okay, number 7 is going to be like our Subway question. If we've got 3 sizes, 6 flavors, and 4 designs, all we do to those numbers is we've got 3 different values. We take sizes, we take flavors, and we take designs, and we multiply those together. So that's going to be 3 times 6 times 4. And that gives me a total of 72 different options. Moving right along, number 8. In how many ways can the first 5 places be decided from 12 players in a golf tournament? Here's where I promised some of you a little shortcut. If I've got 5 places in my golf tournament and I know order is specific, if I took those 5 places just like that, let's call it like a podium or something, first, second, third, fourth, and fifth. How many golfers can come in first? How many have the opportunity, let me rephrase that, how many have the opportunity to come in first? And that would be 12. Then we take our first place golfer away, so 11 have the opportunity at second place, 10 have the opportunity at third place, and all I do is multiply those numbers together. Those of you who use the permutation formula, you will get the exact same answer, but this will save you just a little bit of time with my little shortcut. And so 12 times 11 times 10 times 9 times 8 comes out to be 95,040. 95,040. I don't know why I put a circle around that. I've been boxing everything else. There we go. Make it more uniform. All right. Let's move on to number 9. Number 9, how many groups of 5 CDs can be chosen from 10 different CDs? Chosen, that's a combination because order in this case is not going to matter. And so we are going to have a combination of 10 CDs chosen 5 at a time. So that's going to be 10 factorial all over 10 minus 5 factorial times 5 factorial. So written out, okay, I'm going to save a little time here. I notice I've got 5 factorial on the bottom, so I'm just going to get rid of 5 factorial on the top. And then inside my parentheses, I've got another 5 factorial, because 10 minus 5 is going to give me the 5 times 4 times 3 times 2 times 1. So I can cancel things here. I notice that, what can we do? 5 times 2 is 10. 3 can go into the 6 twice. 4 can go into the 8 twice. That just keeps me from having to reduce at the end. So that gets me to a total of 252 combinations. Number 10. Number 10, we have 50 rolls of film, and how many can be selected? We have 4 rolls, excuse me. So this is another one of my tricks. We have 4 positions or 4 rolls being chosen. How many can be chosen first? Well, I would have 50. Then I would only have 49, and then 48, and then 47. That trick is going to save some of you a whole lot of time on your test. So you can thank me with Dr. Pepper. That'd be fine. And so when I come out and multiply those, I'm going to end up with 5,527,200 different ways of selecting 4 rolls of film from 50 rolls of film. Okay, number 11. Moving right along. Number 11, science class must choose 5 out of 16 science projects to advance in the county competition. Okay, in this one, order doesn't matter. This is a combination because we can select any of the 5. It doesn't make a difference which 5 we select. So this is a combination of 16 and 5. Okay, this gets a little bit crazy, so I'm just going to go ahead and go right to it. Okay, now, on the top, I'm going to have 16 factorial. Now I'm going to stop there because if you'll notice, when I do my 16 minus 5 factorial, that's going to be 11 factorial. So 11 times 10 times 9 times 8, and that's what would have went on right here. But I'm just not going to write that because it's going to cancel with this one. And so all I have left on the bottom is 5 times 4 times 3 times 2 times 1, which is this 5 factorial right there. And now I can start canceling things if I need to. I've got 5 times 3. It'll help me cancel that 15. That 2 will go into that 12 6 times. That 4 will go into that 16 4 times. Oop, that would be a 4. And then I multiply all the way across and I get 4,368. Again, keep in mind, if I'm going too fast for you, please feel free to just rewind and do what you need to do to hear the problem again. Okay, let's go to number 12. Used a lot of pages here. That's okay. Number 12. Okay, number 12, when I total all those socks, there's going to be 40. So I'm going to go ahead and put my n equals 40. And And on number 12, we randomly select a black sock. So that's going to be 16 out of 40. And then I replace it. So then I select a blue sock, and that's going to be 9 out of 40. Okay. And so if I replace it, okay, that gives me 40 choices again. So I'm going to reduce these just because I like working with smaller numbers. 16 is divisible by 8, and 40 is divisible by 8. I can also take that 2 into that 40 20 times, and now multiply straight across. That's going to give me 9/100ths. Okay, 9/100ths, because I was selecting a black sock and selecting the blue sock. That is my reason for multiplication. Number 13. Notice in number 13, it's an OR, so this is going to be an addition. If I randomly select a blue, that's going to be 9 out of 40. Remember, if it's OR, it's always replacement. And so I'm going to add to that, selecting a brown sock, which is going to be 15 over 40. Since those already have common denominators, I'm not going to reduce anything. I'm going to go ahead and use those common denominators. I'm going to add those together, and I'm going to get 24 over 80. Excuse me, 24 over 80. That's horrible math. 24 over 40, because we don't add our denominators. And I noticed that both of those are divisible by 8 as well. So 8 goes into 24 3 times, goes into 40 5 times. So the answer would be 3/5. Moving right along, number 14. Once we get to the back side of the pages, it'll go a lot quicker. Number 14, find the probability. These are just simple probability. There's no two things I have to pull. It's just one. Probability that a randomly chosen customer has visited exactly 2 stores. So I've totaled these up, and we have 280 visitors. And in number 14, they want to know who's gone to exactly 2 stores, so that's 34. So that's going to be 34 customers out of 280 total customers. Again, I'm going to reduce that, and that's going to reduce to 17 over 140. So again, these two questions are just simple one-item probability. Okay, now the next one's a little bit different because it asks how many have visited fewer than 4 stores. So what we actually need to do is we need to add up our 8, 22, 34, and 112. That's because those totals are all the customers who have gone in less than 4 times or fewer than 4 stores. So when I total that up, that comes out to be 176 over 280. And then I'm going to go ahead and reduce that a few times, and through the magic of technology, we are going to end up with a reduced number of 22 over 35. Again, that number 176 came from adding 8 plus 22 plus 34 plus 112, because those are all the people who have visited fewer than 4 stores. Okay, to the back. Now, quite a few questions on the back today in class. Just a couple of things. Typically, in a multiple choice like this, 3 of the answers, especially if it's worded this way, are going to be kind of ridiculous. The question is asking which one of those is a biased sample. Okay, so if we go to an electronics store and we survey people, regardless of what we ask them, it's going to be people who are interested in electronics. So that's possibly biased. Let's take a look at letter B. If I survey or I pull every 15th item off an assembly line, that's totally at random. Letter C, 15 students are randomly selected. That tells us it's totally random. And letter D, a region is divided into separate areas and 3 people are randomly selected. So B, C, and D are all random. A is our biased survey selection. Okay, number 17 we're going to talk about in class, but I'm going to go ahead and give you the answer. Number 17 is systematic. So anytime I pull the 5th item, the 10th item, every 12th person, every 15th person, that is a system. I'm doing the same thing over and over again, so that is a systematic survey. Number 18, the mean absolute deviation of those numbers. So let's get that set up. The numbers are 2, 6, 5, 9, and 3. If I total those up, that's going to be 25. And when I divide by the amount that I have, the mean is going to be 5. So if I'm finding mean absolute deviation, that's going to be 2 minus 5, 6 minus 5, 5 minus 5, 9 minus 5, and 3 minus 5. Those are all absolute values. So that's going to be 3, 1, 0, 4, and 2. So that gives me 10. I divide by my number of items or number of data. So that's going to be 10 divided by 5, which gives me a mean absolute deviation of 2, which is choice A. Okay, number 19. If I'm going to find the standard deviation, I first have to find the variance. So I'm going to total those up. That's 15, that's 26, that's 36. And then I'm going to divide it by the number of items. So my mean is 9. So I'm going to take 7 minus 9 and square it. 8 minus 9 and square it. 11 minus 9 and square it. And finally 10 minus 9 and square it. So that's going to give me negative 2 squared, which is 4, negative 1 squared, which is 1, 2 squared, which is 4, 1 squared, which is 1. So that's going to give me 10. Okay, I divide by the number of items that I had, so that was 4. So my variance is 5 over 2. Now you'll notice in this case they don't want the variance, they want the standard deviation. So standard deviation is the square root of the variance. And so that will be choice G. Number 20. 2 dice are rolled. Again, just scratch out the 3 there. How many outcomes are possible? I've got 2 dice. I've got 6 outcomes on one. I've got 6 outcomes on the other because they're just standard dice. And I just simply multiply those together. So there are 36 outcomes that are available. That is choice B. Number 21. How many ways can 4 chairs be filled by 6 children if order is important? 4 chairs, 6 people for the first one, 5 people for the second one, 4 for the third one, and 3 for the fourth one. Again, that's my little trick that I showed you before. 6 times 5 times 4 times 3, and that's going to give us a total of 360, which is choice F. Getting close. We're in the home stretch. 22. How many ways can a committee of 4 people be chosen from a group of 8 people if the members are selected in no particular order? Okay, so order does not matter. So we have a combination of 8 people chosen 4 ways. So that's going to be 8 factorial all over 4 factorial times 4 factorial. Okay, remember that formula looked something like this. So that's what I just substituted into. Give me a dot there. There we go. So 4 times 3 times 2 times 1, gone. 4 times 2 is 8. That 8's gone. 3 goes into that 6 twice. So that gives me 14 times 5. And that gives me a total of 70, which is choice B. 3 to go. Longest screencast of your life so far, but hopefully it's very beneficial to you. Card is randomly drawn from a standard deck of cards. What is the probability that it is a 2 or a heart? Keyword is or. There are 4 2s in a standard 52 card deck. Or means we're going to add, and there are 13 hearts in a deck of cards. So that's going to give me 17 over 52. 17 is a prime number, so the only option is if it goes into 52, and that's not the case. So we are choice G. Okay, 2 blue chips, 4 green chips, 3 white chips. You randomly draw a blue chip, you replace it, and then draw a green chip. So you're drawing a blue chip and a green chip. That means multiplication. So blue chip is going to be 2 out of 9. You replace it, so you still have out of 9, and you're looking for a green chip, which is going to be 4 out of 9. Blue chip, 2 out of 9. Green chip, 4 out of 9. Okay, so we multiply straight across, and we get 8 out of 81. We would look to reduce that, but that is not going to be reducible. Reducible, is that a word? It is today, folks. And so that's going to be choice C. All right, so it looks like we're going to get to 25 here, and I'm going to keep you right at about 30 minutes, maybe a little bit under. So we're going to randomly select 2 white chips without replacement. Okay, so without replacement. So that gives me, if I have 3 out of 9, and then I don't replace that, so I only have 2 white chips left, and I only have 8 chips left in the bag. Okay, so 3 9s and 2 8s. So in this case, since it's without replacement, I'm not putting them back in. All right. I'm going to go ahead and multiply those together. Okay, we can reduce them. 3 9s is going to be 1/3. 2 8s is going to be 1/4. That should be a times. We multiply through those together. That's going to give us 1/12. Choice J. And that, in a nutshell, is your Chapter 12 review.